everyone, my name is Judy, and today I'm going to take you through a lab on ion selective electrodes. So an ion selective electrode is an electrode that can measure a specific concentration of an ion. So in this case we're going to look at potassium and fluoride, but they can be used to measure many different ions like calcium, sodium, and any other ion really. The advantages of using an ion selective electrode versus some other techniques is that it's a fairly quick analysis process. They're very sensitive at low concentrations, and they're portable as well. So if we need to do analysis in the field, they can be useful in that regard as well. So today we're going to start with looking at potassium. So this is a glass electrode. It's a potassium ion selective electrode. So you can see that it says potassium there. And we use just a regular pH meter for our measurements. Okay, so the ion selective electrode connects to the pH meter the same as a pH electrode would. So let's start with our procedure. So in this case, we're going to use 4 standard solutions to construct our calibration curve. So I have 4 pre-made standards here. If you're not familiar with preparing standards, make sure you go back and watch the video on preparation of a standard solution. So we have 4 concentrations. We have 0.1, 1, 10, and 100 ppm solutions. So we're going to measure all of our standard solutions first, so you can use that data to construct your calibration curve. And then we're going to measure an unknown sample that we know contains potassium, so that we can compare it to the calibration curve to get the amount that's in the unknown sample. So for this procedure, we're going to start with our lowest standard, so the most dilute standard, which in this case is the 0.1 ppm. And this procedure requires 50 milliliters of our standard. Okay, and we're going to put it in a 150 ml beaker here, and it has a stir bar in it already, so we can stir it on our hot plate while we are measuring it. So you want to have it constantly stirring. We're not using any heat on the hot plate, we're just using it for stirring. Okay. So I'm going to start by taking 50 milliliters of my first standard. So I'm going to use a volumetric pipette so that we have an accurate volume. So we want 50 milliliters. Make it at the line. Of course, the bottom of the meniscus at the line is 50 milliliters. And then we'll just let that pour out into our beaker. Take that bulb off, just let that pour. So that's 50 milliliters of the standard solution. There we go. To that, I'm going to add 1 milliliter of ISA. Okay, so that's an ionic strength adjuster. And basically what that is just a buffer that can prevent the interference of any other ions that may be in the solution. So I'm going to have 1 milliliter of the ISA using a Eppendorf pipette. So that's 1 milliliter. So the next thing we have to do now is adjust the pH. So we'll check the pH first with just using pH strips. So these work just by dipping them in the solution to moisten them, and then we compare it to the color chart on the package. So you can see that it is 7.5 or maybe even less. Okay, so it's around neutral here now. So for potassium ion measurement, we want the pH to be higher. We want it to be at least 11, and the high pH avoids interference from the hydronium ions. So that's the reason why we want it to be a fairly alkaline pH. So to increase the pH, I'm going to take some 6 molar sodium hydroxide, which is a strong base, and I'm just going to add 1 drop at a time, okay, because it doesn't take very much to change the pH. So I'm going to add a drop, just give it a swirl to mix, And then I'll test it again using another strip. And now we can see that it's changed. It's probably around 10 or so. So what I'm going to do is add one more drop and test it one more time. There we go. Now we can see it's dark, so it's darker than 10.5. So I'll turn over to the other side, which is 10.5 and up. And you can see that it's pretty well matches up with the 11, possibly even 11.5. So we need it to be at least 11, so that's good there. So 2 drops is what it takes to adjust the pH to 11. Okay. So the good thing about these solutions is they're all water solutions. They're all very similar. They just have different concentrations of potassium. So once we adjust the pH on one of the solutions, now we know that we can use the same amount of sodium hydroxide to adjust the pH on the rest. So we use 2 drops for this one, so we'll just add 2 drops to all the rest. So we don't need to check the rest of them with the pH paper. Okay, so now that we have adjusted, we're ready to take our measurement. So I'm just going to take off this solution that I was just using for storage. We're going to put our potassium solution on the hot plate, turn on the stir so that it's stirring at a nice steady rate. So when we put the electrode in, we want to lower it so that the tip of the electrode is under the surface of the water, but we don't want it to be hitting that stir bar because we don't want to damage the electrode. You also want to check when you put your electrode in that there isn't any air bubbles underneath it, because that can affect your measurement as well. So if there is, sometimes you can just tap it and the air bubbles will go away. Doesn't seem to be any air bubbles there now, so we should be good. So for this measurement, we want to let it stabilize first. So we want to let it stir for about a minute or 2. And then we're going to take our reading on our meter. So it's been stirring for about 2 minutes here now. If we go down to the meter and press measure, see that it flashes for a little bit, and then it should stabilize. And the reader will say ready when it's ready. Should only take a couple seconds because it's fairly stable there now. And you'll notice that the potassium readings are negative, so it's negative 135.1 millivolts. Okay, so now we'll move on to our next standard, which is our 1 ppm. So these ones are already ready to go. So I've added the ionic strength adjuster and I've added the adjusted to pH using sodium hydroxide. So we'll just start our stir over to the center. We'll lower our pH, our electrode. And we'll press measure on the machine again, and then we'll wait 2 minutes for it to stabilize. Sometimes it takes a few minutes. There we go. So negative 83.2 millivolts. So we have negative readings for our potassium. Okay. So now we're just going to switch and move to our next standard. 10 ppm. Lower our electrode again. And come back and measure again. So it looks pretty stable there now. I'll just press measure again. Wait for it to say ready. There we go. Negative 59.3 millivolts. And finally our last standard, our 100 ppm. We'll lower electrode again. Oops. Don't want to hit the stir bar. Okay, so we'll wait for that to stabilize. Okay, so it's just about stable. We'll just wait for it to say ready. There we go, 11.4, negative 11.4 millivolts. Okay, so that's all of our standards. So now we can move on to our unknown solution. And we have an unknown solution that is labeled B. So it's a spiked sample, so we know it contains potassium. And we're going to do that sample in triplicate. Okay, so we're going to do three samples for each sample, obviously. So we'll do it 3 times. Okay, so B1, B2, B3. And again, I have these already measured out and ready to go, pH adjusted, ready to start. So before I do that, I'm going to rinse my electrode, okay, because we're moving between standards and samples now. So we want to make sure it's rinsed. So just use a little bit of deionized water, rinse the electrode, and just dab it off with a Kim wipe. You don't want to be too rough with the electrode because they are very fragile. It's made of glass. So I'll put our B1 sample on, get that one stirring, and lower the electrode. Okay. And again, we'll wait for it to stabilize. Okay, so it's starting to stabilize there now. All right, we have negative 47.0 millivolts, so that's for our first replicate of sample B. And we'll do the second one. There we go. And this is the same sample, so I don't need to rinse in between samples here. Okay, we'll let that stir. Okay, so it's almost stable. Should get a ready sign here pretty soon. There we go, negative 46.9. So it's pretty close to our last one, which is what we would hope for, since they're all the same. And our last replicate, B3. Put on the stir, lower our electrode. Go back to the meter. Okay, so we press measure again. Okay, negative 47.3 millivolts. So that's the last replicate for that unknown sample B. And we'll be back in the next video with the second part of the experiment, which is looking at the fluoride ion. So now we're going to look at measuring the fluoride ion in some water samples. So we're going to use a fluoride ion selective electrode. So I have one right here. So this is a fluoride ion selective electrode, and the fluoride ion is a solid state electrode, which means that it has the fluoride ion embedded in the membrane, and it's usually in the form of lanthanum fluoride for the fluoride ion. So to measure the fluoride, we're going to use a calibration curve again. So we have standards already prepared. So we have 4 standards here. If you don't remember how to prepare them, go back to the preparation of a standard video. So we have 0.5, 1, 2, and 4 ppm for our standards. So let's start with measuring the fluoride ion concentration in our standards. We're going to start with the lowest standard, 0.5, and we're going to work up to the highest. So we'll start with the most dilute, the lowest concentration. So our procedure for the fluoride ion measurement, we don't really need to do any other preparation other than the use of a buffer. So we use a TSAB buffer, so TISAB, which stands for Total Ionic Strength Adjustment Buffer. And basically what that does, it sets the pH at around pH 5, so that helps avoid interferences from other ions that could interfere with the measurement of the fluoride ion. So for our procedure, each of our standards, we're going to use 25 milliliters of the standard, and we're going to put it in a beaker. I already have the stir bar in a beaker, so we can stir it on our hot plate. No heat, we're just going to use stirring. So I'm going to use a 25 milliliter pipette, and I'm going to put 25 milliliters of our first standard. In this case, it's 0.5 ppm. So we need 25 milliliters. And we're using a volumetric pipette so that we have an accurate measurement of volume. So again, up to the line. Air in the bulb again. Okay. So that's 25 milliliters. Put that in the beaker. Let's just take the bulb off so it pours out. Okay, those are 25 mils of our first standard. Now we're going to add to that, again using a pipette, 25 milliliters of our TSAB buffer. Still have quite enough there in my beaker, so I'm going to just get a little bit more. And this stuff comes pre-prepared. We can make it up. But sometimes it's easier to buy things that are already prepared. Okay, let's try that again. 25 mils. Okay. Put that in a beaker with our 25 mils of standard. So that's our buffer. I'll just wait for that to pour out. Patience is important in the chemistry lab. Okay, so that's our 25 mils of buffer. So that's all we need for this measurement. So I'm just going to take off this solution that I already have here on the hot plate, or on the stir plate, and that's just a distilled water solution. So I'm going to turn on the stir so that it's stirring at a steady rate. You don't want to go too fast to create too much of a current that'll affect your pH meter, but you want it to be stirring. So I'm going to lower it down into the solution. Okay. So you want to give it a few minutes, about 2 minutes, just to stabilize before you take your reading while it's stirring. So now I'm going to get you to come around and look at the pH meter. Okay, so it appears our reading has stabilized at 151.1. So our readings for the fluoride ion, for ion selective electrodes, our readings are in millivolts. So millivolts is the units that we're going to measure. So we're going to record that one, 151.1. So that's good for that standard. So now we're just going to move on and do the rest of the standard. So the other standards I have already measured out for us. So our next standard is the 1 ppm, the 2 ppm, and the 4 ppm. So that's a 0.5 we already have done. So each of these have our 25 mils of our standard plus the 25 mils of the TSAB buffer. So our 1 ppm is on the plate right now. Let's measure on our meter. I'll wait for it to say ready. And we expect the millivolt reading to decrease because we're measuring fluoride ions, which is a negative ion. So it's fluctuating just a little bit there, and now it says ready. So that's 139.6 millivolts for our 1 ppm standard. So let's switch to our 2 ppm standard. And because we're working from lowest to highest, We don't need to worry about rinsing the electrode in between because it won't affect our concentration because we're starting with the lowest and working our way up to the highest. So we'll let that one stir for a minute. We'll wait for the reading to stabilize. And as we expected, it's decreasing the number. And it says ready there now at 122.4 millivolts. So that's our 2 ppm. And finally, we have our 4 ppm standard solution. Lower our electrode again. And we don't need the electrode to be down too far as long as it is under the surface of the water. Let's measure again. Wait for it to stabilize. Okay, so it says ready at 105.9. So that's the last of our standards. So the next thing we're going to look at is our sample solutions. So once our standards are all done, we can use that data to construct our calibration curve. And now we're going to run a sample. So we have an unknown sample. In this case, it's just labeled A. So that is a water sample that contains a specific amount of fluoride. It has been a spiked sample, but it's an unknown concentration. So we want to determine what the concentration is. So we're going to record our readings on our ion selective electrode, and we can compare that to our calibration curve. So I have 3 samples already ready to go here. So I've labeled them A1, A2, and A3. So we're going to do it in triplicate. So we're going to have 3 for each sample. Okay. So we'll start with A1. And now because we're moving from standards to samples, I want to rinse in between. So I'm just going to use one of my standards as a waste here. So just rinse the electrode and dab it dry with a Kim wipe. So put on our sample A1, turn on the stir, lower our electrode, and allow our reading to stabilize. Okay, so we're somewhere around 146 millivolts. It's not quite stabilized yet. We want to wait for it to say ready, and there we go. So 146.2 millivolts. So that's our first replicate. We're going to move on and do our second replicate. Because it's the same sample, we don't need to rinse in between now. We'll just lower our electrode again. Press measure on our pH meter. And we would expect it to be somewhere around the same reading, of course, because it is the same sample. These are replicates of our unknown A, which is the same sample. And it looks like it's pretty close. And it is stabilized there now at 146.8. So that's replicate 2. And finally, we have A3, our replicate 3 of sample A. Lower our electrode, let's measure. And again, it's somewhere around 146, which we would expect, which we would hope for actually, that they're close to each other, so we have good reproducibility in our results. So 146.5. So now that you have values for your unknown sample A, you can compare that to the results you got for your calibration curve from your standards, and that will allow you to identify the concentration of the fluoride ion in your sample. And that's the end of that lab. Thanks for watching. We'll see you next time.